For our last example of the week, the campaign staff for a state legislator wants to determine whether the legislator's performance rating has changed in the last year. It's rated from 0 to 100. The table shows the results from 16 randomly selected voters for this and last year. Assume that these responses are approximately normal, and at alpha equals 1%, so be really careful here. Is there enough evidence to conclude the legislator's performance rating has changed? So again, if you want to check these conditions, it's still pretty much free. I want you guys to practice with this stuff. I don't want to trick you. The main thing to pay attention to is that we're looking at a before and after. So it's presumably the same people in each group. So it is presumably a dependent t-test for differences between means. Makes sense for where we are in the book, but hey, it's not that obvious. Anyway, with those conditions in mind, next we want to set up our hypotheses, where in this case we have, jumping ahead of myself, cheating, don't want to do that. Where in this case we are claiming, or at the very least the staffer is claiming, that there is a difference, that the mean difference is something other than 0. It's kind of a subtle way to say that, but if you're claiming that a difference isn't 0, then you're saying there is some meaningful difference. Where the opposite of that is no difference. The means are fundamentally the same. Where that has a null flavoring, this has an alternative flavoring. And then, if we want to get our level of significance, well, what we would end up with is, in this case, alpha is 1%, and we're looking for something in the flavor of 2 tails, because we're looking for any difference. So thankfully that before or after differencing is not as important for us. We have to be quite as careful in our setup. We do want to pay close attention to that as we're actually testing it. Anyway, with that in mind, we can then look at our degrees of freedom. Where here, that's going to be n minus 1. In this case, we have 16, n minus 1 is 15 degrees of freedom. And if we want to deal with this using a p-value approach, we would then need to get our differences values on top of that, where to be sure, I'm going to write those down this time. In this case, we would get a mean difference of 3.3125 and a standard deviation. See, I don't want to borrow for that, jeez. This notation. It gets old even for me. Of approximately 9.67. So, if we want to get our t-score using these pieces, using that formula, t, we plug in that d there, mu d is assumably 0, s goes down there, root 16, we would end up getting that our t-score is approximately 1.369. So, if we want to get our distribution, we'd have a distribution something like so, where in particular remember that we would also get the negative 1.369, and because this is two-tailed, actually, if we got either, we got both, so we don't have quite, again, those same issues that we might have otherwise. But the next thing we would want is to get our p-value, if we're going to run a p-value approach, where here that p-value would end up being approximately, oh, that's the wrong place for this. We'll put the 1 there, 0 there, excuse me. P-value of 190% is a little bit too much. But here, that p-value is much bigger than that. It's not alpha. That's alpha. Close enough anyway. Anyway, p is bigger than alpha. And because p is bigger than alpha, even though this is a different kind of thing we're testing, we still fail to reject the null hypothesis. This is maybe unusual, but not unusual enough to say that there's definitely some sort of change. So, because we are failing to reject our null hypothesis, because that is our p-value as gotten through some form of t-test computation, whether you use table, calculator, whatever it is that you happen to prefer, the final thing we're going to end on here would be something to the effect of: there is not enough evidence for the given level of significance to conclude that the legislator's performance rating has changed. So again, the thing you really should be careful to understand here is when we're talking about testing the differences between dependent means, we're essentially running a t-test on the data set of differences where we're assuming, at least somewhat, if not as obviously as it is here, that there is no difference. That is, mu d we assume is 0. But that's all we have for testing with means. Next week we're going to finish off chapter 8, same way we finished off the last couple chapters, seeing what we can do with proportions.